Welcome to this program hosted by the Beyond Earth Institute. I'm Steve Wolf, President of Beyond Earth. Today's program is being generously sponsored by the Heinlein Prize Trust. We thank the fund, and particularly Art Dula, its leader, for supporting our program and the Beyond Earth mission. To get things started, I want to share with you a 5-minute sponsored video by the Trust. Thanks again to the Heinlein Prize Trust. Before we begin the program today, what I'd like to do is just share with you a few slides and talk a little bit about what's going on at Beyond Earth. Okay. Our mission, for those of you who might not have really looked at our website or heard this before, that we are looking to establish and sustain a policy and legal framework that enables economically vibrant communities beyond Earth. We see that society is poised. We know of the wealthy billionaires that have committed themselves and their fortunes to creating a multiplanetary species existence. This is feeding into a new generation that is raised on science and science fiction, that sees a future where they will be able to one day live and work themselves in space. Much of this is being driven by the extreme reduction in cost of space transportation, and this ultimately will be opening the floodgates for not only satellites being sent into space, but also humans and driving that. And also key space settlement enabling technologies are well underway with such programs as the Artemis moon program and our efforts looking ahead to Mars. So what is this? So in the light of this, Beyond Earth is just looking at a few areas. There's a lot more to tell about Beyond Earth, but I just want to go over some of the areas of focus and research that we're working on right now. We're looking at, we want a national and international declaration of communities in space as a goal, and this sort of builds on the Space Settlement Act of 1988 and recent efforts to make such a declaration. We want to move beyond the question of should we be expanding into space or not? Can we do it or not? We can do it, and indeed we should. We want to identify critical path science and technology efforts, because we want to build upon whatever NASA is doing with the Artemis program. We want to be pushing for critical path technologies that will enable communities beyond Earth. We also want to talk about how we're going to finance it. How are we going to fund this? Public-private partnership arrangements only go so far. So we need to be looking at financing mechanisms and models that really can help to spread the risk across a wide range of stakeholders over a long period of time. It can be done, but we need to be thinking much more creatively than we are right now. We are looking to establishing appropriate rules of law and norms of behavior for those who live in future communities in space and among them. We're looking at what are the permitting and approval processes that may need to come into play. If you're a consortium that says that you have a plan to build a colony on the moon, for example, where do you go and how do you go about that? So we're looking for solutions that not only help us get to that first one or two communities beyond Earth, but we want to set the policy stage for the general expansion of human civilization throughout the solar system. And in order to make that so, we're seeking partners and sponsors to help us achieve this mission. And I want to encourage those that are listening today to be in touch with me to become part of this effort. And I look very much to hearing from you. So now let's get into our program without any further delay. Today we discuss the role of the military and what they will play in the development of communities beyond Earth. With the establishment of the Space Force, there is a heightened awareness of national security considerations on the high frontier. Although the Space Force is currently focused on satellite assets in space, they will increasingly become concerned with the security of the human presence in space. And I want to introduce our moderator for the day, and he'll introduce our various speakers and run and moderate a discussion with them. is Tony DeTora. He's our Beyond Earth Vice President of Policy Coherence and one of our co-founders. Tony is also Vice President of Government Relations at Linked Global, an innovative satellite telecommunications company. Tony also spent many years on the Hill, most recently in the role of Senior Professional Staff for the House Committee on Science, Space, and Technology. And with that, let me turn the program over to you, Tony.
Thank you, Steve. Thank you very much. So the last few years have witnessed a dramatic increase in the interest and funding for national security efforts in space. This attention is to be expected. The economic importance of space is increasing dramatically. Nations around the world are rapidly increasing their space capabilities, as space assets and activity have never been more important to the security of individual nations and the world. But where is the line beyond which a nation is militarizing space? If we look at the Outer Space Treaty, Article 4 says the establishment of military bases, installations, and fortifications, the testing of any type of weapons, and the conduct of military maneuvers on celestial bodies shall be forbidden. The use of military personnel for scientific research or for any other peaceful purposes shall not be prohibited. And then the use of any equipment or facility necessary for peaceful exploration of the moon and other celestial bodies shall also not be prohibited. In matters of policy, we have important questions. Where are the lines drawn? How are they drawn? And by whom? Technologies are content neutral. Good actors can use them to improve lives, and bad actors can use them for nefarious purposes. A system designed to redirect a near-Earth asteroid away from an Earth impact can potentially redirect one into an Earth impact. I know this is James Bond villain stuff, but it is an important consideration, even if maybe not at that scale. How do you establish safeguards, legal and policy frameworks that prevent nefarious actions while enabling the other ones? How do these safeguards impact the prospects for the development of human communities beyond Earth? Can militaries support the development of key technologies, such as critical infrastructure elements? Might space become such a critical environment for Earth-bound security concerns that it undermines economic vibrancy in space? And what might be the expectation for a national or international security presence aboard large-scale human habitats? These are some of the questions we'll consider in our program today. I will give a brief introduction, and the full bios of our guests are available on the Beyond Earth website and on many other fine websites around the internet. So if you'd like to get that, you can go to our website. But I would like to now turn it over to Gordon Roesler. Gordon is president of Robots in Space LLC, and Gordon is going to share today the latest work at the Defense Innovation Unit and the space infrastructure research that the DoD is supporting. Gordon, welcome.
Thank you very much, Tony. I'm glad to be here. I am honored, actually, to have been selected to give this talk. I want to be clear at the beginning, I am not representing the U.S. government or any of its agencies. I consult to industry and academia, as well as small part of the government. And everything I'm going to say here is really my own view. Much of it is taken from public information, and the rest of it is inference on my part. The title I have here is Human Expansion and National Security in Space. As you can see, my one-man consulting company is called Robots in Space LLC. A lot of what I'm going to talk about is uncrewed actions in space. Let's see. But at the end, I hope to be able to show you how this connects to human expansion and human operations in space as well. A lot of what we're going to talk about today is logistics, getting things around in space. Where we're starting from today is we have great logistics for the International Space Station. The Cygnus, the Dragon, the European, Japanese vehicles, the Progress and Soyuz going up to the space station, provide lots of supplies, lots of support, human transfer. On the other hand, if you think about satellites, they don't get that kind of service. They are alone and unafraid. They're never inspected, they're never maintained, and they're never repaired. And that's an issue that some of my work in the past has tried to correct. And you just ask yourself the question, where else in things we do you spend $1 billion on something and then you never inspect it, you never maintain it, or never repair it? That's a problem that needs to be addressed, and hopefully you'll see a path forward as a result of this talk. Another issue is that the way launches are scheduled, they're chartered, right? It's not like going down to Southwest and getting on an airplane because you know what the schedule is going to be. It's a charter system, and it primarily depends on the primary payload, right? We do launch hosted and secondary payloads sometimes, but there's an intimate relationship between the delivery of that payload and the launch schedule. If the payload slips, the launch slips, everybody pays for that in terms of increased labor costs and so on. Something else that we hope to address by a new vision, a new paradigm for space logistics. We know that launch vehicles, have a maximum mass that they can deliver to any given orbit. We often don't reach that mass. Instead, the volume of the fairing is the thing that determines what can get launched and what can't get launched. And that's a limitation that some new technologies are perhaps going to address. And finally, if we want to move from place to place in space today, we can only do that by reducing the life of the spacecraft that's there. They don't get refueled. So thank you. Where do we want to go, right? What is the end state we're looking for? Satellites getting the same care as other highly expensive systems, being provided by a logistics system. I'll call it a national logistics system for now, but it certainly could be international, that services everybody who wants to do things in space. It services the commercial providers at GEO. It services NASA, who wants to build new telescopes in space using robotics, and it services various military needs. To do this kind of thing, like we have in terrestrial logistics systems, you're going to want some standard things, standard interfaces to plug new electronics and propellant in, standard procedures. And we'd like to move to a situation where launches happen on a routine schedule, that payloads are delivered, and if they're late, that's all right, you'll get on the next launch. It'll be coming in a month. We want to bolster our supply chain, which today, for various components, is very fragile. And we'd like to get a lot of propellant in orbit that allows us to move around without regret, that doesn't limit the life of our satellites. So, since the question is about national security and what is the military's role, I want to point out this unclassified document called Challenges to Security in Space that was released by the US Defense Intelligence Agency. And it describes many practices and many developments that are going on in China and Russia that are very concerning from the standpoint of stability and security in space. That both of these nations view counter space capabilities, ways to destroy or degrade space products, as a means to reduce US and allied military effectiveness. I would simply point out that that will reduce every benefit that we get from space systems. They are very focused on having a military organization that enables military space operations, and they're developing a wide variety of capabilities to degrade our space systems. So if some people question the creation of the Space Force, and I would point out it's simply in response to these obvious developments by some potential adversaries. As I mentioned, I want to focus on logistics. And there is a tie-in between logistics and military operations, but there's also a tie-in for every other kind of space operation, including human expansion. But first, I point out that from the military's point of view, space mobility and logistics is one of their core competencies of the US Space Force, as laid out in their Space Power Capstone document, which is available on the internet, by the way. I will quote a military phrase: if you're not thinking about logistics, you lose. There is no field of warfare that doesn't involve logistics, and space will in the future be no exception. What is space logistics? Well, Today, it's simply a rocket that goes to a destination, leaves something, and that's that. Whether it's a Dragon capsule or a Soyuz or whatever. We're thinking about in-space transportation that can be reused the same way that SpaceX today is reusing their first stages. The benefits of reusability done properly are apparent from an economic point of view. But what are they taking these logistics to? They're taking them to depots, which could have humans in them, or they could be completely uncrewed, operated only by robotics, and stations where payloads are hosted, robotics are tested, large structures are manufactured. We would like to see the entire space infrastructure move to a more modular, more commoditized way of doing business that, as everybody knows from terrestrial industries, these are the ways to take real advantage of economies of scale. We see modularization as providing a speedier response to events, but also speedier introduction of new technologies. Instead of having to take a new sensor and integrate it with a complete satellite, we'd like to be able to take it to a station and plug it in. We do that on the International Space Station today, and we'd like to propagate that modality. By allowing modules rather than full spacecraft to be the end product, we can expand the industrial base, reduce costs, and now getting away from that chartered launch situation to a cadence launch where it is scheduled like an airline. People don't like to use things in space that haven't been in space, so there's a real chicken and egg problem, but by enabling a more low-cost qualification approach through modularization and hosting on orbit, we want to lower the cost of getting flight heritage. And if this is a national infrastructure, the government will just be one of the customers. NASA will be a customer, the Space Force will be a customer, the geo operators will be customers, the gateway will be a customer, even the lunar surface will be a customer of this expansive space logistics infrastructure, which looks something like this. Very crowded slide, a lot of different potential applications and how it all works kind of thing. The orbit arc that I show here is a geostationary orbit. That's what I call the boardwalk of today's space infrastructure. That's where the dollar value is. $120 billion a year in bits go out to the geostationary orbit and come back to Earth. On the left-hand side are some systems that already exist or are nearly ready to be launched on orbit. Northrop Grumman's Mission Extension Vehicle, which is able to restore and maintain orbits for geostationary satellites. DARPA and Northrop Grumman's Robotic Servicing of Geosynchronous Satellite program that I had the privilege to lead for 4 years, that will launch in 2023 to enable repairs and external upgrades of geostationary assets. And if you look at the right-hand side of the column are some new capabilities that will be able to be introduced in the near future, where we make the robotics less expensive, where we put platforms up that can host payloads. We make our geostationary assets serviceable. We give them the equivalent of USB ports where we can plug in new electronics and a standard gas cap like you have on your car so that we can refuel them frequently. And we can bring modular payloads up there that allow us to reconstitute in the event of a damage. One of the keystones of this architecture would be high delta V space transport vehicles. Some people call them space tugs. I prefer space cargo liners. I have a Navy background, and I think of a tug as something that moves around at short ranges, inside ports, and that sort of thing, whereas liners go large distances. This is that reusability aspect that I mentioned before that will reduce the energy requirements on the launch vehicle and give us the benefits of reusability. And I just point out that for very little additional propellant, that cargo liner, that tug, if you will, can go not just to geostationary orbit, but to cislunar space and even beyond. Once you're in low Earth orbit, as people have said, you're 90% to the rest of the solar system. This is not science fiction, okay? The technology is with us. We've shown it frequently. Way back in 2007, DARPA had an experiment called Orbital Express, 2 spacecraft that repeatedly docked with each other without any human inputs, robotically assisted. Propellant was transferred. 2 different modules were replaced that picked up the activities when they were plugged in. So it's been around for a while. There just hasn't been the customer pull to use that technology, but we now see that customer pull coming. This year, for example, Lockheed Martin announced that the next generation of GPS satellites, the 3Fs, will be serviceable. They will have interfaces on them for refueling and for electronics upgrades. 2 years ago, there was a major event that happened in geostationary orbit. Northrop Grumman's Mission Extension Vehicle docked with an Intelsat satellite, pushed it back into the geosynchronous orbit, geostationary orbit, and is providing station keeping for it, extending its life. If the CEO of Intelsat, Steve Spangler, says, if a satellite is making money, why would I want to throw it away? And now we've proved that you don't have to do that. The long life components can continue to be used and maintained. 2 years from now, roughly, the DARPA Northrop Grumman RSGS system, which is a 2-arm robotic system, will be launched to provide repairs of minor things like solar panels that don't extend properly, in very close inspection of mechanisms that you want engineering data on, and adding new modules to the exterior of spacecraft. So this stuff, these technologies are with us. Okay, so I showed this diagram before. And as I said, there are people, both in government and industry, that would like to see this become a whole of nation infrastructure. One set of assets that serve everyone's needs to the best that they can. Today, we have a lot of these systems up there. The mission extension vehicles, RSGS will be up there shortly, but they're not tied together. The geostationary satellite constellations are today, each one of them is isolated. And infrastructure can tie them all together. And now you'll start getting economies of scale for things like propellant deliveries, for things like electronics upgrades. This can also support the Artemis mission. And as we know, people are very interested in harvesting propellant using the ice at the lunar poles. Someday you're going to want to get that back away from the moon to other places, and a logistics infrastructure will help to do that. This can also supply the components for robotically assembled large telescopes in space. There was a study done a couple of years ago that I had the privilege to be part of called In Space Assembled Telescope, far larger than the James Webb Telescope that will launch later this year. Robotically assembled, it will need the parts to put it together. Communication operators today are stuck with whatever they launch. We would like to be able to upgrade their payloads on orbit so that when customer demands and populations change on the Earth, the satellites can respond to those customer changes instead of becoming obsolete. We can provide frequent technical upgrades, and that includes military satellites. Today, we're plagued by very long procurement cycles. We want to be able to shorten those considerably, and this logistics train will do that. It'll get us to that cadenced launch drumbeat that I keep mentioning. We really want to get to a more scheduled and less chartered environment in launch. And it'll provide opportunities for new companies that aren't qualified or don't have the heritage of building fully integrated satellites to fly things, to test things, and to profit from the expanding space economy. Okay, so how does this all connect to Beyond Earth and your mission of policy and legal frameworks for expansion? There's a famous billionaire who has said that his goal is millions of people living and working in space. And to that I say, fine. But for every one of them, there should be 10 or 100 robots. And that's not just because my company is called Robots in Space. You don't have to feed robots, they don't have to sleep, and when one of them breaks, you don't have to have a funeral. You will have to have robotic repair personnel up there because robots do break, but they're more efficient at doing, especially repetitive. What we used to say at DARPA is you want robots to do tasks that are dull, dirty, and dangerous. And clearly human operations in the vacuum of space and even on planetary surfaces are quite dangerous. So the more support that we can do with robotics for them, the better. That infrastructure that I showed in that very busy diagram of an Earth orbiting logistics system will prove out the technology that we will later need for human expansion further into the solar system, whether it's to a planetary surface or O'Neill cylinders or whatever. And where the logistics trains for those colonies are simply scaled up versions with somewhat longer legs than the system that I showed. And so getting the nation and perhaps the entire world together into a space logistics system then provides a springboard, provides the supplies we'll need, provides the emergency response that we'll need, all the sorts of things that we get from terrestrial logistics systems to maintain freedom of space, which is the military's job, just as the Navy's job is to maintain freedom of the seas, as well as providing the support for colonies that are up there for the expansion of humanity in the solar system. So that's all that I had. I appreciate you all being here and listening. I look forward to hearing your ideas during the question and answer session. And this is how you can get a hold of me. Thank you so much.
All right. Thank you very much, Gordon. We'll bring you back on in a few minutes to join our panel. For now, I would like to introduce our next presentation will be from Barbara Belvisi. Barbara is founder and CEO of Interstellar Lab. And Barbara brings an important perspective because we wanted to make certain we're not just US only viewpoint. And so Barbara, hopefully you'll bring that well to us today. So I'll ask you to take your microphone off mute and then we'll get your presentation up.
Thank you, Tony. Hi, everyone. I'm very happy to be with you today. It's an honor to present during this Beyond Earth Institute session. I'm a big fan of what you guys are doing and really supporting your mission. I hope we can contribute. So to bring the international perspective, so I'm born in France, but I actually spend a lot of my time between the United States and France. My previous company was between San Francisco and Paris, and this one is between Los Angeles and Paris. Though with the pandemic crisis, we had to adapt a little bit and grow the team in France. Hopefully, I will be able to come back very soon to Los Angeles and put our team there and the assembly line over there. So I'm going to share a little bit about what we're doing and then open the perspective on how I can see the military can play a role in the field we are at. So we're a little bit different. We're not in the satellite. We're not in propulsion. We're not in rockets. We're into a developing food system. So let me share a quick presentation here to give a little bit more of background. So Interstellar Lab, we're a startup, young company. So as I said, based between Los Angeles and Paris. So a very international team. And what we're working on is to help building bioregenerative world. So it's combining technology with biology and to create environments, controlled environments where life, nature can thrive. So as a company, our goal is to build and to sell products so we can help this dream of becoming a multiplanetary species. And as often as what I'm saying is that multi-planet implies two planets. So before we go to the moon or set on Mars, there is a need to install a system here that can help us live in a sustainable way. And space exploration has always been helping humans doing so. And so we're trying to push that and to help this a little bit more forward. So what we're developing is an environmentally controlled module, so a completely sealed module where we control the air, the atmospheric condition, the climatic condition inside, and we recreate an environment where we can grow food and at the same time recycle the air, recycle the waste, recycle the water. We design those modules to be in a close future on the moon, and then in a a more longer future on Mars. But right now, to work as a standalone units on Earth, they can also be plugged together, but they can work completely standalone. So the first unit we've been working on is this one, is the crop cultivation system. So for companies that are trying to develop life support system for space settlement, there is this problematic of also finding a sustainable business model, because we're talking there about going to the moon, back to the moon 2023, 2024, and then putting there a sustainable moon base. But meanwhile, developing all this technology, there was a huge need for a company like us to find business model on Earth. And so that's also one of the reasons we've been focusing into developing this system, because this has a application for sustainable food production on this planet. And so we basically took a lot of approach of designing a life support system in space, understanding what are the nutritional requirements for a crew of astronauts in space, to design algorithm and software that will help us select the crops and organizing everything that we need to grow inside the biopod, the previous dome that I was showing you. So it's very I finding a very exciting and appealing to use space design, space approach, space thinking, space methodology, and to come up with solutions that actually are solving a lot of the problems that we have here. For instance, just to dive a little bit more into the product, but by reusing atmospheric water, atmospheric generator, exactly like you use in space to recover the water, it can help a plant growth system to use much less water than traditional system. By controlling the CO2 and the O2, you can really play with the atmospheric condition and recreate specific environmental condition inside the dome, so you can grow any species. And by using material that are traditionally used in space, like aerogel, for instance, which is one of the materials we're using, we can reduce the energy consumption of a traditional crop cultivation system by a factor of 20. So space technology is definitely helping us on Earth. Those are some of the focus some of the things we've been focusing on growing into our biopods. A thing that is not mentioned here is everything that is around biodiversity conservation. So when you can recreate, of course, there is the business side of what we do. Growing flowers for the cosmetic and perfume industry, growing specific exotic fruit for the agro industry, which are terrestrial business model. But there is also an aspect which is about protecting life and how we can recreate specific climatic condition to grow endangered species and to protect the species. This is a case study that we're doing for a very famous luxury brand that has issues about sourcing their raw materials and accessing very rare flowers they use to produce their perfume, so they can use our technology to grow the flower they need instead of traveling on the other side of the world and jeopardizing the biodiversity of those places because they're doing perfume with those rare flowers. So it's a very local solution. Again, it's how we transform the space approach, some of the space technology, into something that is much more affordable, that is very responding to a business case here on Earth. And of course, part of what we're doing is to work on we want to work on the sustainable moon base and participate into the Artemis program on how we can design a greenhouse to be on the moon. To tell a bit more, the biopod that we have right now is absolutely not designed to be on the moon. We need a lot of iteration on the material system that we're using. Right now, it's absolutely not solar radiation proof, so we have a timeline of 3 years to do that. We need to change the HVAC system because what's working on Earth is not working on the moon. And we need to do a couple of iterations on the aeroponic system that we're using to grow plants, so it can work on the moon. And so that's basically about us. But I want to say a few words on the military role and how we can help companies like us that are focusing, in developing bioregenerative life support solutions. So here it's a little bit specific because we're talking about, plant cultivation, biology, and hardware. And this is not only about satellites. and so the military yet hasn't been playing a huge role in financing and helping technology like we are developing, but I think there is an opportunity as well to apply such system and such technology and into problems we're facing. We're facing, as I was saying, on Earth right now, and more specifically, to deploy into extreme environmental system that will allow anyone to grow food in a more durable way. So what I'm expecting and what I'm hoping in the future is that we've seen in the United States the military and is really helping the space industry move forward. We can see in France there is a bunch of space program and French president has been making some announcement during this pandemic and pushing really forward to invest more money into the space industry. Most of them are really focusing into satellite launchers and security. But I'm an optimistic by nature, and I hope to see that also the money will go towards finding more durable solution and sustainable solution here, and this is where I see the military going, more of the money going also in the coming year, and especially when it comes to developing space settlement on the moon and in the future on Mars. That's for me right now. I'm eager to jump into the panel discussion.
Great, thank you, Barbara. Very interesting stuff there. I'll have questions for you after, once we get offline, about your system. So, great. So now I'd like to bring back in Gordon. And I'll also bring in Greg Autry, who is the Clinical Professor of Space Leadership, Policy, and Business at Arizona State University. He also serves as Beyond Earth Vice President for Economic Vibrancy. Welcome, Greg.
Glad to be here. Thank you.
Great. And then we'll have also bring in Doug Loverro, who is President of Loverro Consulting, LLC, former Associate Administrator of NASA's Human Exploration and Operations Mission Directorate, and former Deputy Assistant Secretary of Defense for Space Policy. Those seem very relevant today. Welcome, Doug.
Great to be here, Tony. Thank you.
Great. So, Doug, let's start with you. We just had a couple of very interesting presentations and comments, and I'd like to get your views of what we heard as it relates to not only short-term needs, but in the longer term, how it can apply to economically vibrant communities beyond Earth.
Sure. Well, Tony, thank you, and Barbara and Gordon, thank you for your presentations. Fantastic views of what we could do in the future. As I think about this question and the real question that we're dealing with here today, which is the use of militaries in space and the role of the Space Force in space exploration, it's interesting. I try to put some things in perspective. Perspective number one is our nation, and in fact all nations in the world, have gone to space in general for three primary reasons. Number one, to seek military advantage, and that really was one of the big reasons why Eisenhower began our program and the Russians began their program back in the early 50s. Number two is for exploration, and we're all very familiar with the exploration mission. And number three is for economic gain. And if you really want to break down everything that the world has done in space in the past, it falls into one of those three categories: military advantage, exploration, and economic gain. And the military advantage, when we talk about the military advantage part of that, is military advantage on the Earth, not to necessarily gain military advantage in space, but to use space capabilities to gain military advantage on the Earth. Whereas the other two, exploration and economics, are to go ahead and make money off of the process of going to space or to explore space. So it's a kind of a different view of the world. Now, I'm in big agreement with what Gordon said in terms about the use of robots and the need for robotics in space. You want to do long-term exploration in space. A robot can be on the moon with no logistics tail for 365 days a year, and the human beings need tons and tons of water and food brought to them in order to do it. And Barbara talks about how we're then going to go ahead and produce those kind of things on the surface of planets, and those are both elements of the exploration mission. Both what Gordon talked about and what Barbara talked about become elements of an exploration mission from a sense of those three pieces that we just discussed. And so you have to kind of think to yourself, so what causes what creates the need for a military in space that's not focused on military advantage on the ground? Where would you need the Space Force to go out and actually do things in space that weren't focused on enhancing terrestrial activities, but were in fact focused on the actual act of exploration or the actual act of economic development on these other celestial bodies. And the answer to that is the same answer that we find on the surface of the Earth. We have conflict where there is advantage to be gained and limited resources or limited capabilities to be had. And if you use Mahanian terms, this would be, we would call some of these choke points, for example. Or we would go ahead and have conflict over oil in the Middle East. So we're going to see conflict in space where we have a limited resource that others desire and that would be willing to go ahead and use militaries to go ahead and get advantage of. I always find it interesting to look back in history. You know, Columbus came to the New World in 1492, and of course, Columbus was not a military man, although he may have had a military background. He was an explorer. He was exploring, and he was looking for economic riches for Spain and for Europe. When the Jamestown settlers came to the New World, almost 120 years later, they were investors. They weren't military members. They were investors. They were looking for gold. But conflict began to break out because people were interested in the same property, in the same minerals, in the same advantages that they could go ahead and gain. Militaries followed exploration. Militaries followed economic development. They didn't go there first. They went there second to go ahead and defend those limited resources. I think the real interesting question for space is, where will we find those limited resources that militaries are necessary to protect, that forces militaries to go out and follow the economic and exploration activities that occur? And I'll stop there so we can get the books in there.
Thanks, Doug. Greg, I'd like to hear your thoughts on both the presentations and then trailing off of what Doug said.
Yeah, thank you. And thank Barbara and Gordon for their presentations. I'm particularly interested in seeing kind of the positive things that the military can bring. I understand where Doug is going about conflict over resources, and I think that's inevitable. And I'm going to be honest, I think there's kind of a worship of the Outer Space Treaty, and nobody wants to touch it. But I think without a lack of sovereign territory on the ground, we're inviting conflict. Once you can define who's in charge of the kinetic enforcement of law within an area, then you're much less likely to have conflict. Under the current very definitions of operational exclusion zones or non-interference zones, I think we're inviting a problem that nobody wants to deal with, and it's got to be dealt with. I'd like to talk just real briefly, because I noticed some fool on Twitter immediately responded to my post about this conversation as there is no role for the military in space. And I'd like to do some history too, just real quick, but more recent history. If you look at where we are in space, we would not be anywhere near where we are if it wasn't for the military need to do what Doug had pointed out, which was to gain military advantage on Earth. The launch vehicles were military funded. If you just look at the difference between what Goddard got trying to do a peaceful liquid fuel rocket development and asking for US government funding, he was really excited when the Smithsonian gave him $10,000, right? And what did von Braun get when, unfortunately, he chose some very nefarious venture capitalists? He got the equivalent of billions of dollars of funding in today's dollars, and he got the job done and put a vehicle into space in 1942 and laid the groundwork for both the Soviet and US space program. So the military funding made the difference. Solar power, global positioning system, the internet, everything to do with Earth imaging these days, all started because there was a military need to do it. And it started decades and decades before any commercial actor would have gotten to it. Frankly, I think we might be on a equivalent of a CompuServe bulletin board right now if ARPA hadn't put funding in back in 1961 in reaction to Soyuz to push connectivity between U.S. entities. So the military is going to drive these things and has a valid and helpful role in doing so that's very positive. It is not just about conflict. By trying to prevent war, by securing a better understanding of what your opponents are doing, or creating capabilities that dissuade somebody from attempting to do something territorially that we'd rather they didn't, is not necessarily a bad thing. So let me open it up to that, and thank you.
Great, thank you. So Barbara, I'd like to hear your reactions to these, your response to these reactions first, and then we'll get back to Gordon about logistics infrastructure.
No, but I can't agree more with what Doug and Greg just said, and the role it plays over time, and going back to history and what happened since the beginning of a space exploration. I mean, it's pretty obvious. I really like how Doug presented things about the exploration, the economic need, and the military kind of a control of terrestrial control. I actually have I never thought of it, and it's if you think about it and then you organize like this, then you yes, definitely.
Okay.
Yeah.
I imagine Doug spent a lot of time thinking about it. So. So I'd like to go back to Gordon now for a second. You're saying that a single national space logistics infrastructure would be tremendously beneficial. And can you give a terrestrial example of what that might look like, and what would be the wider implications of that as we look, obviously near term, but at enabling communities beyond Earth?
First, I want to thank Doug for using a naval analogy. I began my career as a naval officer, and when he cited Alfred Thayer Mahan, I got very excited. I mean, honestly, it's been said, whenever there is a line of commerce, it must be defended, and Mahan gives a lot of theory about that. And I'm actually personally disappointed that the Space Force decided to retain Air Force ranks instead of going to the Navy ranks. After all, it's not Colonel Kirk, it's Captain Kirk, right? So we're going to have to fix that someday in the future. Terrestrially, let's look at containerization, right? So this is the work on containerization started in the 50s with McLean and his shipping containers, and a bunch of interfaces had to be created. You had to stack containers on containers. You had to fit containers to ships and the correct interfaces there. You had to interface them to railroad cars. You had to interface them to trucks. Well, once you did that, I mean, I wouldn't say that containerization is the reason we have globalization, but it's hard to imagine globalization without containerization, right? And so that's the kind of model that we're trying to push into the space environment. And it's good for everybody. I mean, it really is. As far as the military is concerned, one of the biggest problems we have is our long, as Doug is well aware, our extremely long acquisition cycles. Right, we get an idea, and maybe we get that idea in orbit 15 years later. I don't know how to change that from an administrative point of view, but if I can build systems just faster and test them more frequently and at less expense, I'm going to improve that situation. So the containerization, modularization kind of thing is, plays right off of that. I noticed that all of Barbara's growing modules look pretty much the same, right? They have the same kind of geometry and that sort of thing. That's what you want, right? You want things that fit, in a standard way inside your lander on the moon or your lander on Mars or whatever, things that people know how to handle. They're not changing with every iteration. Modularization kind of forces people to stay inside certain envelopes, but it's a good and powerful thing. So that terrestrial ship, rail, truck, and even different kind of trucks, right? There's big trucks and little trucks, and air freight, right? That's all part of the picture as well. It all works together pretty much seamlessly. And you have professions that we don't see in space right now today. You have dispatchers and freight forwarders and multimodal transportation experts and those kind of things. Someday we'll have those for the space environment as well.
Very good. I know we're going to lose you in just a minute, Gordon, because you have another commitment. So thank you for joining us. And I'm going to move now back to Doug. Doug, I'm going to tie this back to our sponsors. So the Heinlein Prize Trust, as you know, some of the themes in Robert Heinlein's works are about threats from beyond Earth and the militarization of space and what those implications are for societies on Earth. So I don't know how familiar you are with his works, but I think we all are in some way, shape, or form, even if we haven't read them. So the presence of a military service, or we could call it a security service in space, whether on the moon or in a deep space facility, it implies protection from a threat. So what are the threats we would be trying to protect against? And is it simply a matter of terrestrial concerns, protecting those things that you said, the resources that are under, different limited resources, or something else?
Yeah, Tony. First of all, I am a big Heinlein fan, so I mean, I think that there's nobody who goes to space who hasn't read Heinlein, and everybody else as well. And
Naval Academy graduate, by the way.
There you go. And by the way, I also want to comment on something Greg mentioned on CompuServe. Man, I haven't heard CompuServe for 30 years. So, Greg, thank you for reminding me of those awful times. Just 2 nights ago, I was refreshing my memory on planetary defense, on the question of asteroid defense, specifically not hostile aliens, but hostile alien objects as planetary defense. And quite frankly, that's probably the biggest threat from external to the Earth that we face, that a military will indeed have to have a role in. And by the way, I want to go ahead and second what Greg said. He is absolutely right. The military has empowered investment in these kind of areas over many decades. Not just this was true for air travel. This was true for rail travel. It's true for space travel. I always remind people that the interstate system in the United States of America was funded by the National Defense Authorization Act, the Eisenhower National Security Interstate System. The military right now is the lead in the United States for investing in solar power for both military uses and eventually for economic uses. But to your question, Tony, on the defense, I think the first question about defense that we need to think about as a military is that planetary defense mission from asteroids. And it's interesting that nobody has really wanted to step up to that role. One of the reasons why myself and others were so insistent on going ahead and trying to create a space force, and Gordon was a compatriot in that, Greg was a compatriot in that. One of the reasons that we did that was because, from my view, I wanted a military service, a branch of the military, who viewed space as their birthright, as their place to operate, as their AOR. In the same way that a naval officer will view the sea as a place that he's going to be, the space folks will view the space as the place that they have to operate, not necessarily be, but at least operate. And therefore, they have to start to take responsibility for things that we did not want to take responsibility for previously. That would be, for example, negotiations on rules of the road in space. Before the Space Force existed, nobody in the DoD wanted to talk about that. Now, the Space Force is talking about that. I think the Space Force will rapidly talk about planetary defense. You've seen the Vice Chief of Staff of the Space Force, General Thompson, talk about debris mitigation in space as one of the missions that they think, because now the military is responsible for that. That, by the way, is the second threat to things in space right now, is debris mostly left over from military activities that still flies around unpowered in space, and in fact harkens back to Gordon's question about how do we have a logistics trail, not just to get things up to space, but to get things back down again. So I think that's the place. I think there's always going to be a role of military, that exploration and military investment. Those two sides of that three-sided triangle that I talked about, those are always connected. in ways that are symbiotic usually. Greg talked about the early launch vehicles. I always try to remind my friends at NASA that NASA only ever built 3 launch vehicles in their entire existence. The military built like 50. So it's it's a very different viewpoint when you have a military focused on space as their operating location. They suddenly start to accrete to them responsibilities that they would not have accreted to them if they were still an Air Force or Naval Force. And I think planetary defense is one of the first ones they're going to go ahead and deal with.
Okay, very interesting. So, Greg, as we look at the activity of the Chinese and Russians, are they getting too close to the militarization line? How large of a concern is it that they're working together, and what their plans are? And one of the hallmarks of future communities beyond Earth will be self-governance. Do you think Russia and China can be on a path that leads to that?
Wow, that's a handful of questions. Do we have another hour? Let me just say again, I do think there's a problem with the sovereignty issue, and it's clear that some people like Elon Musk are already basically saying someday we're going to go off and claim our own sovereignty, and we care less what the OST says. And getting the Chinese and Russians, sometimes the sum is greater than the whole of the parts, and I think in their case the sum will be a lot smaller than the whole of the parts. So I encourage them to work together. I think that's the best thing that can happen for the U.S. and other Western countries, is for them to form an axis of evil with North Korea and probably Iran, and everybody will love that, and it won't work very well. That said, I don't see anything specific that they're doing that I think is threatening from a military standpoint, but I do see these issues of interpreting what the non-interference zones in the OST means. If somebody goes and places a nominally scientific station in a critical resource area and draws a big circle around it, saying your rocket plume can't come down in here, there's going to be issues, and how they're going to be worked out is not clear. So good luck to them.
Thank you very much. Barbara, did you have a viewpoint on that question as well?
No, I just want to jump in, like, apart from space, actually, if you think about it, and that's more my previous investor hat, but actually military has always been on the edge of the state-of-art innovation, and always looking for as much innovation as possible, whether it's in robotics, in computer vision, and of course it was mostly linked to military. Sorry if I use the wrong words, but domination, or winning war and having the best equipment for the crew, but it's been helping making giant leap in technology advancements, in artificial intelligence, in AI, computer vision, as I said. So having more investment from the military going into space, of course, it's going now with a focus that is much more onto launchers and satellites. But if we talk about the future and the sustainable moon base and becoming a multiplanetary species, and getting on the moon, and how we deal with the settlement and installation, then it will also go towards financing innovation and technology. So not only solar, but like water, foods, and all those things. So so I think that the question is to which extent, how far can the military go? Where do we define the boundaries of militarization? And so that's linked to the question that you were asking about China and where they stand right now. So it's a very hard question, and Greg managed to answer.
Well, that's why we're asking the experts, right? So, all right, I'm going to ask a question now that we ask of all our guests. We'll get Gordon back on the back end, but Greg, I'll start with you to put you on the spot. When do you expect we will see the first economically vibrant, self-governing community beyond Earth?
Wow, self-governing. 2032 would be a date I'll put out there.
Writing that down, 2032, great. Okay, Doug?
Let's see. you said economically vibrant, self-governing on out of Earth. So that's different than when do we set up our first settlement on Mars. I actually think this is a very long process, quite frankly. Again, I'll harken back to Columbus arrived in the New World in 1492. The Jamestown settlers arrived in 1607. Most of them died that first year and didn't become economically viable till the Germans showed up a year later with food and logistics. I think this is a long time scale. I am fairly clear-eyed in understanding. I think how difficult it will be to sustain a settlement on Mars, and if you want to have a self-governing, economically viable settlement, that means that settlement has to produce its own food, its own water, and it has to have a source of economic strength separate from the lifeline that it has back to the planet. So that's a pretty tall order. I think we'll certainly have settlements on Mars well before that. But when you say self-governing and economically viable, that requires a long, in my mind, a long time scale. So I'm going to put that out somewhere in the 2150 timeframe.
2150. The term I used is economically vibrant. I don't know if that'll change your date, but
Yeah.
rather than viable.
And let's be clear, I'm differentiating self-governing from sovereign. So self-governing means that they have determination over the enforcement of laws within their own LEO container or moon base. I'm not saying that they are removed from any association with the sovereign U.S. government or another government on Earth.
As I mentioned earlier, Greg is our Vice President of Economic Vibrancy, so he had to weigh in there. So, and Barbara, same question. First economically vibrant, self-governing community beyond Earth.
Somewhere around 2040, so I'll be in in between.
Very good. All right, we've got a couple of questions that have come in through the comments. So we have a question about what are your thoughts about the medical logistics tail needed, and what has been done in preparation for that? And that can go for anyone.
I can jump in, Tony, if that's okay.
Yeah.
So we actually were doing some studies on this when I was in charge of human exploration back at NASA, about what kind of problems would show up in space travelers and what kind of medical care they needed. Obviously, the first consideration was making sure that folks were either trained or you had a actual licensed physician in many of these things. When you go to the space station, if you get sick, you can come back down pretty quickly. That's not going to happen when you're and even in the moon, if there's an injury or something like that, you can get somebody back to Earth. That's not the case for planetary exploration for Mars. You are on your own. So you've got to go ahead and have trained individuals, and you've got to have medical supplies for. And we actually did. I mean, literally, the study. I didn't do it, but the medical folks who help us in the exploration thing did the study. What are the all of the common medical conditions that could happen either because of biological concerns or because of accident, and what equipment would you need in order to go ahead and deal with those things, and what skills would you need to deal with them? We actually had a very detailed analysis of all of that question, and all of those supplies and all of those capabilities and all of those instructions were indeed they will indeed be part of whatever we send to a planet like Mars. Even the communication time lag between Mars and the Earth doesn't allow a feedback of, oh my God, I just cut a vein. What do I do now? You better know what to do now, because you can't wait the 8 minutes to go ahead and get the answer. So it's it's incredible just how difficult and how complex that question is. And it's so important. I see a comment from Dan Hawk. He says, on our submarines, sometimes we had a medic, but no medical doctor. Exactly. We've dealt with this in in military operations all the time. I mean, how many of us have seen a World War II movie where the cry goes out, medic, right? And if you don't get that medic there in time, that individual is going to die.
Yeah. Okay.
Yeah, I'd like to chime in there, and I do think this is a huge challenge to Mars, and I'm much less sanguine about a Mars colony. I think a moon colony and a orbital colonies are much more likely. You can do robotic telesurgery, for instance, with those perhaps, which you're just not going to do on Mars. But just the prescription meds for chronic conditions is going to totally limit who can possibly go to Mars. And people are likely to develop things like diabetes while they're on Mars. What are you going to do? You have medications that won't even survive the travel time to get to Mars, even if you could afford to send them at gosh knows how many thousands of dollars per kilogram. So I think that the Mars colony is highly constrained by the medical question. And that's why I'm much more interested in what happens in cislunar space in the next 30 years.
All right. Great. Thank you. Barbara, do you have anything to add? Or
No, not specifically, but I think it will be possible on Mars only when we'll be able to, to come up with solutions to develop our own meds directly, on site, and because they will not survive transportation, and it will take 20 minutes communication delay. So relying on Earth for that will not be possible, but it's doable, but it will take a long time.
Okay, absolutely. All right, I see by the clock that we have run out of time, so I'm going to invite Steve back in to the studio here to turn it back over to him.
Yeah. Before you all go, I really appreciate an extraordinary conversation. I think one of the big things that takeaways for me is better understanding that the military is and the role that they're playing in developing these key or critical path technologies that we're going to need ultimately to help us establish these communities beyond Earth, and especially from a historical perspective. And it's not so much about conflict resolution and that sort of thing. And it does sort of imply that that it is in our national security interest that we are developing these technology. And so perhaps that could even mean that it could even mean that for the nation to promote and help to enable communities beyond Earth is indeed a national security issue as well. So interested in sort of continuing to pursue that line of discussion. I really appreciated Doug's comments, about how difficult really it is. Right, and we need to be very clear-eyed about that. That when we talk about creating communities beyond Earth, it is, we're going to get to the moon, with Artemis, and that in and of itself is no easy task. And so going from there to a self-governing, economically viable community of a community that's maybe 50 or 100 or 1,000 people, we have to be very clear-eyed on what that task is ahead of us. But knowing that the task is difficult is not the same as saying that we shrink away from it, right? So that's really what Beyond Earth is all about. So anyway, I want to thank you again, Barbara, Doug, Gordon, Greg, and of course Tony for your expert moderation. I do want to say to everyone that this event is recorded. I know that there were some issues with people finding the location where where we were showing the event. So it will be recorded, and we'll be sending out information to everyone who registered so that you can watch the whole event. And I also want to thank our sponsor again, the Heinlein Prize Trust, and I look forward to everyone's participation in Beyond Earth. Please do be in touch with us. We are, as we move into what I call the next phase of what Beyond Earth is doing. It's going to be exciting time. So we're looking forward to your all engagement. As I mentioned to the speakers before the call, we're looking at their participation in this event really as a starting point. We're looking for their continued involvement in our activities as we move forward. So thank you all again, and we look forward to seeing you next month. Just as a quick preview, next month we focus on the advanced financing models that we need to be considering in order to fund these large-scale macro infrastructure and habitat projects we're discussing. So look for the information on that. And thank you all again, and we'll see you next time.
Thank you, Steve.